in this lecture, we'll discuss about the essence of dispatch, and we will see that it is important to let the receiver decide. So first of all, let's start with an example that we already saw in a previous lecture. This is a Boolean example with multiple classes. So here you have two subclasses, true and false, subclasses of the Boolean class. And when you send a not message to an object, it will correctly respond whether it is the true instance or the false instance that receive it. Okay, so we never test exactly which object receive the message not, and based on the class of the receiver, it will respond accordingly. So what's the point of this example? So in this lecture, we will focus on why is it really useful? Because probably you will never re-implement Booleans in the future, because in most object-oriented languages it's already there. So what are the lessons to learn, and what are the properties of this solution? So imagine we have more than two classes. Instead of having just true and false, we have a lot of classes. Here we have a huge hierarchy of classes. And now imagine that you need to implement a new method, and inside this method, you will have to test, to introduce some condition for each cases for different classes. So how you will do that? So we will not test each case. In fact, we will use message send. And sending a message selects the right method to execute based on the class of the receiver. This is what we saw in the Boolean example. And it can be seen as a condition without explicit if. This is a dynamic choice, so you don't need to explicitly test in your code. Let's take an example. For example, here we have a collection, here, of multiple objects that are instances of different class. So A is an instance of the class A, B is an instance of the class BB, etc. And now we send the message operation to each of these instances. And basically, it will answer correctly according to the class of the receiver. So we never tested that it is the method A, the method operation from A, or the method operation from BB. It's already automatically done by the message send, by the lookup. It will select the right method in the right class, given the receiver class. And this solution is even better because we can introduce, for example, a new class in the hierarchy. Here we introduce the AA class, and we have a new instance in the collection. And here what happened is that I didn't change the client code here. This is exactly the same code, and it will work perfectly. So this is an extensible solution. So sending a message is a choice operator. It means that each time you send a message, the execution engine, the virtual machine, selects the right method depending on the class of the receiver. So the next question is, how do we express choices as a programmer? So let's take these two designs. Could we have the same Boolean solution with only a single class, like here? Will it be possible to implement the not method and the or method without if? And the answer is no, of course not. If you want to have an implementation without explicit if in the code, you need to have multiple classes. So it means that the classes play the roles of the case. They express the choices in the code. So it means that a class represents a choice. This is the important point. So now that we understood this point, we can compare something more general. We can have a fat class here on this side, and here we have a hierarchy of classes. And now we understand that the hierarchy of classes is a better design because this is a more modular design. We isolate each point in a different class of hierarchy. We don't need to introduce complex conditions in the code because we will just send messages and the right method will be explicitly chosen by the lookup algorithm. And then we can even specialize the behavior inside subclasses. We don't need to recompile existing methods because when I add a new class, I can introduce new method inside this class and it does not change the code of other classes. and we can only focus as a programmer on one class at a time, so one given concept at a time. So the message dispatch support modularity. And for example, we can even, with a hierarchy of classes, we can even package classes. For example, the class D here, we can package it in a separate package. And this is better from the modularity point of view because it means that this package, this is not mandatory to load it. We can load it dynamically as a plugin, for example, or we can even not load it at all. And then if we load this extra package, this plugin, client's code does not change. This is what we saw in the example before. It means that instances of the D class will correctly work with all client code without changing it. So message send is powerful, and message send has supporting choices. The execution engine acts as a conditional switch, so it means that you need to use it. You don't need to test explicitly in your code. But for that, you need to introduce hierarchy of classes to have cases. And then this is an extensible switch statement, a kind of extensible switch statement by adding new classes in your hierarchy. The second message in this lecture, this is let the receiver decide. Sending a message to an object means that there is a lookup algorithm that will select the right method to execute. So client does not decide. You send the message and you let the lookup algorithm decide which method to execute. And the client code is more declarative. It means that you give orders to messages and they will answer correctly. And then, of course, we can have different receivers that we can substitute dynamically. So it means that if we load an extra package, an extension, a plugin, and there are new objects, they will answer correctly without breaking the client code. So in summary of this lecture, what is important to remember? Avoid conditional as much as possible in your code. Use objects and messages whenever you can. Let receiver decide. Do not ask. Tell your object what to do and let the system select the right method to execute. And the class hierarchy supports dynamic dispatch. So use class hierarchy and introduce more classes in your design.